we're going to take all of our factors of 6, and we're going to put that over factors of 1. So in other words, factors of our constant divided by factors of our leading coefficient are our possible rational zeros. So this is going to result in, well, the factors of 6 are going to be 1, 2, 3, and 6. Factors of 1 is just 1. So our total possible are going to be positive, negative of 1 divided by 1, which is just 1, 2 divided by 1, which is 2, 3 divided by 1, which is 3, 6 divided by 1, which is 6. And we're going to make sure to use braces and not parentheses. If these were parentheses, you would be saying it's anywhere between 1 and 6. All those numbers would work except for 1 and 6. So don't use parentheses, use braces. Or if anything, don't use anything. Just put plus or minus 1, plus or minus 2, plus or minus 3. So if you're not sure what to use in these, just individually list them all out. All right? Don't get points taken off because you did all the work, but you put parentheses. All right? Cool. I'm going to hold off on questions from the homework to see if we have time after the lesson or we have time on Monday. Plus, we're doing a big chunk of what we did for homework as 2 examples on here. So hopefully if you had questions, it would be answered in the lesson. So we're going to go ahead and kick off. Are there any questions on this? The other class had a great question. I just want to bring it up because they graphed it and they said not all of these were zeros. But like I said, not all of these have to be zeros. In fact, none of these might be zeros. It might have no zeros. These are just your possible ones. These would be the, if I made you on a test say you can't use a calculator on this, these would be the numbers you kind of plug and chug your way through. So you would see if 1 goes into it, -1, 2, -2. If I would do that, I'd probably pick one of these earlier ones to be your zeros, just so I could see your trial and error, plugging stuff in and checking. All right, we're getting into kind of where we left off yesterday, where I talked about roots and how roots can tell you how many zeros you have. These are not potential zeros. These are exactly how many zeros a polynomial has. So that gets us into the n-root theorem, which says the degree of the polynomial is the number of roots it has, including multiplicity, imaginary numbers, irrational numbers. It is all of those zeros it's going to have. So when we're looking at something like 6x to the 5th plus 24x cubed equals 0, and I say find all of the zeros, it'd be good to know how many zeros I have to be looking for. So we're just going to look at the highest power that we have, which is that 5. And I'm going to immediately know that I have 5 zeros. Because it's a 5th degree polynomial, it has 5 zeros. Let's go ahead and find all 5 of those zeros. Well, anytime I have x's that look like I can factor them out, I'm going to do that before I do anything else. So let's factor out as much as I can out of here. Well, I can see that 6 goes into 6. 6 also goes into 24. So let's bring 6 out front. I have x to the 5th, x to the 3rd. I'm also going to pull out an x to the 3rd. Now we have 6 divided by 6 would give me 1. I'm not going to write 1. X to the 5th divided by x cubed. When we divide, we subtract. So it's 5 minus 3 gives me x squared. Plus 24 divided by 6 is 4. X cubed divided by x cubed is just 1. So we just have that. I always check really quick. Is 6x cubed times x, that would be 6x to the 5th. Yep, that's what I wanted. 6x cubed times 4, that would be 24x cubed. Okay, we're good. I always check the other direction just in case, because people make silly mistakes on tests. Where all of a sudden 24 divided by 6 turns into 3. Well, now I have something times something equals 0. That's our zero product property. Either this equals 0 or this quantity equals 0. So let's focus on that 6x cubed. Either 6x cubed equals 0, in which case x would equal 0, or x squared plus 4 equals 0. Let's go ahead and solve that. I would subtract 4 on both sides. We would have x squared equals a negative 4. I would take the square root of both sides. We'd have x squared, or x equals plus or minus negative 4, which is going to be x equals plus or minus 2i. That's 2 zeros. That's 1 0. If my math adds up correctly, that's only 3 zeros. Where are those other 2 zeros? Any thoughts?
Is it the plus or minus?
It isn't the plus or minus because I counted both of them. There's 2 of them. This is 1 0. Yeah. X cubed counts for 3 zeros. Because picture what x cubed actually is. This is actually saying 6 times x times x times x. This x can be 0. This x can be 0. This x can be 0. This is called multiplicity. Because this is 3, this actually accounts for 3 zeros. So this 3 right here tells you that you have a multiplicity of 3. So those are actually 3 zeros plus 2 zeros equals 5 zeros. So multiplicity of 3 plus these 2 zeros equals 5 zeros. They're all accounted for. All 5 zeros are accounted for. It's key that you recognize multiplicity, because when I tell you to find 5 zeros and you think you only find 3, now you're spending a whole bunch of time on a test trying to graph stuff, trying to look for stuff on zeros that don't actually exist. You already found all 5. A similar one, but slightly different in the fact that how many zeros does this one have? How many zeros does the next one have? Anyone want to take a guess? I'll take a guess. 2. I'm wrong. I'm super embarrassed now. Now, can someone else take a shot at it? Liam?
7.
There are 7 zeros. There are 7 zeros. Even though it looks like 5 is my biggest power, we are multiplying. So if I would actually square this, we'd have x squared times x to the 5th, which is x to the 7th. So if we're multiplying by powers, we actually have to take this 2 and add it to this 5. So we have 2 plus 5 equals 7 zeros. That's key because on the test I can definitely have a section I'm just like, how many zeros does each of these have? Don't find them, just tell me how many zeros you have. Which can be a quick or a long, painful one. Let's actually find all 7 of our zeros. So my first 0 is x minus 3 equals 0, in which case x would equal 3. How many of those do I have, though? How many x equals 3s do I have? Yeah, Liam.
1.
1 or
2.
2. Yep, because it has a multiplicity of 2. It's because it's to the 2nd power. All right, our next one, we have x plus 14 equals 0, which means x equals negative 14. Someone besides Liam, because he got me the other one and the other problem. How many zeros do I have? 5. So that's my multiplicity of 5. That gives me 7 zeros. I was supposed to have 7 zeros. Awesome. I don't do any more work. That's a pretty easy problem. Questions on multiplicity and how many zeros I'm supposed to be able to find. It's just sometimes nice when I have a polynomial and I'm looking for, and I say find all your zeros, to know how many you're looking for versus just blindly going down a path of not knowing when you have to end. All right. This part right here, And I'm going to specify that this will be on the test. And I do that because anytime I just do a quick blurb on the bottom of a page, I feel like it gets forgotten about. And it's such a small section. It's kind of like, if you remember that Mississippi one, how many different ways did I spell Mississippi? I told you it was on the test, and a lot of people got that wrong, and they didn't study it because it was on the bottom of a page, kind of hidden. So once again, this will be on the test. I will have a question just like this on the test. And that is the conjugate pairs theorem. If a plus bi is a root of a function, then a minus bi is also a root. So anytime I give you an imaginary number as a root, I actually gave you two possibilities. So if I give you I, you're going to say, well, that means negative I is also a root. If I give you 3 plus I, you're going to say, well, 3 minus I is also a root. I'm not going to list all of those. Like here, I'm saying in this one that the polynomial has roots or zeros, 2 and 1 minus I. To get our full points on this question on a test, you have to be good enough to recognize that that also means that 1 plus I is also a root. So even though I gave you 1, you actually have to think of the other one. Every single time I give you an imaginary root, the flip version of it, or the opposite pair, will also be 1 as well. All right, now we're supposed to find a polynomial equation with roots 2, 1 minus I, and 1 plus I. Let's focus on the 2 first. So what it's saying is 2 is a 0 of this function. So when I plug a 2 in, I need to get 0 out. The easiest way to do that is to just start with x minus 2. Because now when I plug a 2 in there, 2 minus 2 is 0. All right, then we're going to focus on the 1 minus I. Well, to get that, all we're going to do is x minus 1 minus I. Because now when I plug that in, I would get 0 out. And finally, to deal with that 1 plus I, we're just going to do x minus 1 plus I, because now when I plug that in, it would give me 0 out. That is all I'm looking for on this question. The only thing I'm going to do is I'm going to rewrite this as f of x, because it says write it as a function, equals x minus 2 times x minus 1 minus I. I don't even need to distribute that negative sign. And then we have x minus 1 plus I. So for these, I don't even need to simplify. I did not write simplify. I just said write a function. On my answer guide, I think some of them I did distribute, but I said you can list it as this, or you can have the distributed out form. I don't care. It doesn't say simplify, it just says list a function. This is a function. That's all I'm asking you to do. So all you have to do on these problems, take those roots and do x minus that root. So if I gave you a negative 2, you would do x minus a negative 2, which would become an x plus a 2. Questions on that? We're good? That makes sense? All right, don't get that wrong on the test. It's either going to be really easy or you're just going to lose easy points. Okay, so now we're going to do some practice just like we had on the homework last night. Where I'm supposed to find all the solutions to 2x cubed minus 5x squared minus 6x plus 4. But now we know where we're ending. We're ending once I find 3 zeros. And we're going to start out just like we did yesterday. We're going to find all of our potential zeros. So let's find all of our potential zeros by going, okay, we're going to do factors of 4. Are going to be over factors of 2. My factors of 4 are 1, 2, and 4. My factors of 2 are 1 and 2. So all my possible zeros are positive, negative. 1 divided by 1, which is 1. 1 divided by 2, which is 1/2. 2 over 1 is 2. 2 over 2 is 1. I already counted that one. 4 over 1 is 4. And 4 over 2 is just 2. I don't need to include that again. This could be one I put on a test that I say you can't use your calculator on, because there's only 8 possibilities. This is definitely one that you could trial and error your way through it, where you'd plug in a positive 1, then try a negative 1. Then try a positive 1/2, then try a negative 1/2. Then a 2, negative 2, 4, and negative 4. Hopefully by then you found which one is your 0. We aren't going to do that. We're going to go ahead and take out our calculators, as I saw some of you already do. Graph it. And come up with what you think is the 0. Okay. So since 1/2 is a root, x minus 1/2 is going to be a factor, because me plugging 1/2 in here gives me that 0. So if 1/2 is a root, x minus 1/2 is a factor. And then when we write the second half of it is just 2x squared minus 4x, oh, not plus 8, but minus 8. And we got those numbers from here. So we divided by 1/2, which drops our power down to a quadratic. Now we can start finding our zeros. One of my zeros we already found was x equals 1/2, but we already knew that. We already knew that by divided by 1/2. 2x squared minus 4x minus 8, well, I can find that 0 because it's a quadratic. I can either factor it, complete the square, or I can use a quadratic formula. So, once again, this can also equal 0, so 2x squared minus 4x minus 8 equals 0. I'm going to start you off with a little shortcut. Divide everything by 2. Since 2 goes into everything, why not divide everything by 2 to give me x squared minus 2x minus 4 equals 0. Now, I'm going to complete it. I'm going to complete the square. I'm not going to talk you through it. I'm just going to do it up here. So feel free to either complete the square or put in a quadratic formula to see if you come up with the same zeros I do. But while you guys are working, you can glance up. I will be completing the square. But try not to just follow along with me. Try doing it on your own. I do get out 1 plus or minus square root of 5. I personally like completing the square a lot, especially with easy numbers, and I don't have to factor something out, just because it's this quick. Right? Quadratic formula always is going to be the same amount of steps. It's always going to plug all those numbers in, take out your calculator, plug stuff in. This I didn't even need a calculator. It was just real quick, easy. That's why I like complete the square. Well, we had 1 0, x equals 1/2. These were 2 zeros. I came up with 3 total zeros. I go back up here and say I should have 3 zeros. I'm done looking. Those are all 3 of my zeros. Now, if you would use your calculator to try to find these, you couldn't do them because these are irrational numbers. These weren't part of this list because these are all rational. These are irrational numbers, so we had to use that one rational number we knew to get those 2 irrationals. Which leads us to, any questions? Cool. It leads us to one that's a little more difficult. This is x to the 4th. This is x to the 4th, which means I need to pretty much knock that down 2 power levels. X to the 4th I can't deal with. X cubed I can't deal with. I need to get down to x squared before I can actually deal with it. We're going to use our calculator a little bit more on this one. We're going to use our calculator a little bit more on this one. And we're going to do what's down here, and I'm going to walk you through it. What I want you to do is I want you to take out your calculator, and I want you to type in x to the 4th minus 4x cubed plus 7x squared minus 16x plus 12. I want you to make sure you're zoom standard and stay on that graph unless you can figure out those buttons. But I don't want you going on a left tangent and then we have to wait for you to catch back up. All right, so we hit second, calculate, and ask for a left bound. You should have an arrow on it. If you don't have an arrow, hit left or right until you can see this flashing arrow. Left or right. If you can see, I have a, mine just shifted all the way over there. That's fun. So if you look, I have this little flashing X here. You got to move it. You're going to use left or right to move it.
I can move it up there?
Yes. So if you don't see yours, just hit right or left until you can see it up here. Most likely you have to hit right until you can see it, because it just means it's off the screen. Down here it should say what your x value is. Can anyone not locate their x thing? What is your x value? Say x equals 10. So you're going to hit left, because right now yours is way at x equals 10. You're going to hit left until it comes back. All right, we are going to look for this 0 right here. It asks for a left bound. So you're just going to make sure this flashing x is to the left of this 0. Anywhere to the left will work, so I'm just going to put it about here. It's just to the left of it. And I'm going to hit enter. Then it's going to ask for my right bound. Now I'm going to hit right until I'm right of that point, which is about here. And I'm going to hit enter again. Then it's going to ask for a guess. Usually guesses don't matter, but if you want to, you can get close to that 0 and hit enter a third time. Not all of our calculators ask for a guess, so I'm just asked for a left and right bound. And then you're going to hit enter one last time, and it should come up with x equals 0. X equals 1, I'm sorry.
Oh, yeah. I got it.
That means x equals 1 is for sure a 0 of our graph. All right? This method only works when it's a nice number like that. If it came out to 0.1234877, that means it's a square root or something, and you would actually have to find it by hand. But we now know x equals 1 is a 0. Let's go ahead and find the other 0 that we see here. So I'm going to once again go ahead and go second, calculate. I'm going to calculate a 0. It asks for a left side of it, so I'm going to go on the left. Doesn't really matter where you put it on the left. And then I'm going to go to the right of it, which maybe is here. Make a guess. Hit enter, and you should be able to get x equals 3 out. Did we all with calculators at work get those two values? Stuff, guys. I could tell people that went home and actually practiced their calculators on the stuff, and those of you that just kind of laughed it off and didn't do anything with it. You're going to be able to use your calculators on the test, so those that know how to use a calculator, yeah, that's going to be so easy on this test versus people that do not. And I'm going to tell you on the test, I'm not going to spend a whole bunch of time teaching you how to use your calculator. So if you're like, I don't know how to calculate a 0, too bad. We did it in class, and you're supposed to practice it on the homework. All right. So I'm going to go back to my screen, and I'm going to say by calculator. So we used our calculator. By calculator, I found out that x for our roots, we have x equals 1 and x equals 3 are our zeros. Yes?
So why couldn't you use the other way? Like, you said something about the x to the 4th makes it so that you can't do it the normal way.
Can you put in a quadratic formula?
No.
Can you complete the square?
No. Well, you could do... Oh, never mind. Yeah,
Nope.
you're right.
So we can't do x to the 4th until we break it down to an x squared. Yeah.
So anytime, like on the test, if there's something like x to the 4th, like try putting your calculator first.
Yeah, unless I say you have to do it by hand. In which case you have to. So read the directions carefully.
Yeah.
Because some I might just say, if I just do this, find all real imaginary roots, you can use whatever method you want. You can plug in your calculator, find your zeros, do it just like this. If I say list all of your possible zeros, and then solve it, all I'm asking for is to list these, then you can use your calculator to find which one works.
Okay.
If I say no calculator, that means you have to list all of these and guess your way through it. All right, so just read the directions. So if I just list it just like this week, you can use exactly what we did. Find your zeros that are possible. I found it x equals 1 and 3. And once I know 2 of my real zeros, this is how we're going to do this. We need to get from x to the 4th to x squared. So what I'm going to do first, since one of my roots is 1, I'm going to divide 1 into it. So I'm going to use synthetic division. Basically, I'm checking, double checking. So we have 1x to the fourth, negative 4x cubes, 7x squareds, negative 16x's, and a 12. We're going to use synthetic division, which means drop that 1 down. 1 times 1 is 1. Negative 4 plus 1 is negative 3. Negative 3 times 1 is still a negative 3. 7 minus 3 is 4. 1 times 4 is 4. Negative 16 plus 4 is a negative 12. 1 times a negative 12 is negative 12. It does come out to 0, which is awesome because we already knew this, but now we know for a fact that x, so we have x equals 1 is a root.
Will we have to check this other test?
You have to use this method because I'll show you why. So I am less checking this. I am more doing something that we have to do.
Okay.
All right, it just happens to also check it. I now can rewrite that equation as x minus 1. Since 1 is a root, when I plug it in, it should turn to 0. So that's why it's x minus 1. And then I'm going to rewrite the second part as x cubed minus 3x squared plus 4x plus 12. And remember, I got all that from here.
Is it minus 12?
Oh, minus 12. Yep. Thank you. And I'm going to set that equal to 0 again. So I know x equals 1 is a 0. I still have this stupid x cubed. I can't put this in the quadratic formula. This is why I had to find 2 zeros. Since 1 is a factor of this, we got down to this. But since 3 is also a factor, I can now divide this section by 3 to reduce this even further. So we're going to do one more step here with synthetic division. This time I'm going to bring the 3 in. I'm going to bring the 3 in, and I'm going to use this. In other words, I'm going to use these numbers right here. So I'm going to use 1x cubed, negative 3x squared, 4x, negative 12, and I'm going to synthetically divide that. So we drop the 1. 3 times 1 is 3. Negative 3 plus 3 is 0. 3 times 0 is 0. 4 plus 0 is 4. 3 times 4 is 12. Negative 12 plus 12 is 0, which is good because that means x equals 3 is a root, but we already knew that. But now we can rewrite it even further. We can now rewrite this as x minus 1 times x minus 3 times, well, this is x squared plus 0x plus 4, so it's just x squared plus 4 equals 0. Once again, I got that 1 from here. I got that 4 from here. I am going to copy this and put it on my next slide because I ran out of room. We're not quite done. Is everyone okay on this slide, or should I hold on for just a second? Mike, you're still writing.
Good.
You sure? Don't let me go too fast. Okay, then I'm going to copy and paste this on the slide. So we're going to start where I left off with, we already knew x equals 1 is a solution. We already knew x equals 3 is a solution. What we use both those to do is to get this part here where x squared plus 4 equals 0, which would be x squared equals negative 4. Take the square root of both sides, choo-choo, choo-choo, which gives us x equals plus or minus, well, we have to have an I in it. Square root of 4 is 2, so it's 2I. I now have 1, 2, 3, 4 zeros. I was supposed to have 4 zeros based upon its x to the fourth, right? Do I have any more zeros to find? No, I am done. To go on Anna's question, she asked when, most likely, Anna, on a problem like this, I'm going to let you use your calculator the whole way.
Yeah.
Because because I'm actually looking for this step here. Can you use a 0 to get to the next 0? One like this could be either way.
Okay.
Because it is only 8 possibilities, I could make you guess and check your way through. Reminder, homework, not due till Tuesday. Monday is a work day. Homework's due on Tuesday. Wednesday's another work day / review day. Thursday's the test. All right, everybody have a wonderful day. Good luck on your presentations.